before we start the thesis presentations proper, it looks like we have a good number of people watching, which is great. This is obviously not how we thought thesis day or graduation would go when we all assembled in Cambridge almost exactly a year ago. But the work that this class has done was already impressive in March and is all the more impressive for what happened from March afterwards. It's really incredible that you all were able to support each other and pull together and get through what I think was without doubt the hardest academic year that anyone has ever faced or even thought about facing, at least in our lifetimes. So an incredible congratulations to all of you. I hope that you all are overwhelmingly proud of yourselves and each other. It breaks my heart that we cannot do this in person, but I look forward to a day very soon when we can all celebrate in person. And I'm really excited to hear about everyone's theses. So if we still, is Shannon, is Mara still not here? And if so?
She's not here yet.
Okay, so who were the first three? Who are we gonna do between 12 and 1?
So I was supposed to go first, and ideally I would keep that slot just because of a timing thing on my end.
It's Rachel, Ashley, Kate, and you know what? Why don't we just have Rachel go ahead, and we'll incorporate Maura as she comes.
She can do it. Maura can do a postscript congratulations as opposed to a precursor congratulations.
Sure.
So Rachel, take it away.
All right. Cool. So thanks, Shannon and Seth, for kicking us off, and thank you to everybody who's showed up from various parts of the country and various parts of the world to listen to us talk about our theses. As Seth said, it's been a strange and long journey to get here, but we did it, and I'm really excited to hear about other people's theses, and I really appreciate that so many people came out to sort of help us celebrate, even if it is on Zoom this year. So I'm going to kick things off by talking about the subject of my thesis, which is that little guy back there, the black-footed ferret. And to do that, I actually do have some slides, so I'm going to try sharing my screen. Let's see. Okay. So the title of my thesis was Plague on the Prairie, the Fight to Save Black-Footed Ferrets from the West's Most Insidious Disease. And so today I'm going to talk a little bit about the black-footed ferret and its conservation story from basically being presumed extinct to having a really successful captive breeding effort that brought it back from the brink of extinction. And I'll also talk a little bit about the major barrier to its full recovery, which is the plague. So first, I'll tell you a little bit about what a black-footed ferret actually is. So black-footed ferrets belong to a group of mammals collectively known as mustelids. They tend to be kind of like long and tube-shaped and carnivorous and sort of cranky, and they punch above their weight, and include animals like stoats and pine martens and wolverines. But black-footed ferrets are unique in a couple of different ways. So black-footed ferrets are the only ferret native to North America, and they also have a really interesting strategy for getting on in the world. So black-footed ferrets are entirely dependent on prairie dog colonies for their survival. They eat prairie dogs as over 90% of their diet. They also live most of their lives in prairie dog burrows and raise their young in prairie dog burrows, and are really a part of that ecosystem. So unfortunately, black-footed ferrets are also one of the most endangered mammals in North America. There are only about 300 to 350 of them alive in the wild today. This map, those numbers are black-footed ferret reintroduction sites. And this kind of reiterates that if you don't have prairie dogs, you are not going to have black-footed ferrets. So all of those sites overlap with regions where there are very healthy prairie dog colonies. And as you can see, they're spread across the Great Plains and even nudge up into Canada and down into Mexico at the extreme edges of their range. So black-footed ferrets were actually presumed extinct in the 1970s and were rediscovered in a quite unusual way in 1981. And I quite like their rediscovery story, so I'm going to share right now a really brief passage from my thesis about their rediscovery in Meeteetse, Wyoming. On September 26, 1981, the Hogg family was about to sit down to breakfast at their family ranch in Meeteetse, Wyoming, when Lucille Hogg, the family matriarch, noted that she had heard their ranch dog Shep raising a commotion the previous night. Suspecting Shep had picked a fight with a porcupine yet again, she sent her husband John out to investigate. But the tube-shaped animal he saw lying on the ground was a creature he had never seen before. Perplexed, John took the animal inside and laid it out for his wife and kids to see. Lucille announced that she liked the exotic look of it and wanted to have the creature stuffed and mounted for her mantle. So when the family drove to town to run errands later that day, John put the strange animal in a sack and threw it in the truck. After they visited the post office, the family walked across the street to the local taxidermist. But upon seeing the contents of the sack, the taxidermist got a strange look on his face and rushed to the back of the shop to make a call. When he returned, he informed them that his suspicions had been confirmed. The Hoggs had brought in a black-footed ferret, a species that was presumed extinct and last seen alive in the wild 7 years prior and 500 miles away. He informed the Hoggs he would have to confiscate the animal immediately. Lucille never did get to see that ferret mounted on her mantle. So Shep the ranch dog may very well have saved black-footed ferrets from extinction. Biologists never found another population of black-footed ferrets in the wild after that point. Every ferret alive today is descended from that population. And in fact, once that taxidermist called in the ferret and biologists descended on Meeteetse, Wyoming, they found a population of about 100 black-footed ferrets. But a few years after that, that population started to rapidly decline. And at the time, they didn't know why. Several decades later, they realized it must have been a plague outbreak. So US Fish and Wildlife made what was a very desperate and risky call of actually pulling all of the remaining black-footed ferrets they could find into captivity and leaving them in the hands of captive breeding. So once they decided to do this, there really weren't that many ferrets left. And they were able to find 18, and only 7 of those were able to pass on their genetics to the next generation. So every ferret alive today is descended from just 7 individual ferrets. So luckily, that gambit paid off, and the captive breeding program wound up being really wildly successful, to the point that techniques developed in the black-footed ferret program have actually been used for captive breeding for animals like snow leopards and even the giant panda. I was lucky enough to be able to visit a captive breeding facility at the Phoenix Zoo in January, which now feels incredibly lucky, and get kind of a behind the scenes peek at what this looked like. So all of these photos are photos that I took when I was visiting the facility. And it's crazy how much of a science this has become. They monitor the ferrets for their readiness to breed for months in advance. They have a stud book that keeps track of every single ferret that's ever been born. Every ferret is assigned a number and potential mates to maximize genetic diversity in the ferret line, and they will drive the ferrets across the country if their perfect match is in another facility. So I visited the Phoenix Zoo. There are 5 other facilities spread out across the US and 1 in Toronto. So the captive breeding program has actually produced over 9,000, probably closer to 10,000 black-footed ferrets now since it began in the late 80s. And over 5,000 of those have been released at the various sites that you saw in the previous map, which might leave you wondering why, if that has been so successful, there are only about 300 alive in the wild today. And there are a number of challenges that ferrets face in the wild. The usual suspects of habitat loss and losing territory. Prairie dogs are also quite maligned by many in the West and are targeted with poisoning and shooting, which makes it challenging for the black-footed ferrets to survive. But everybody I talk to who works in this program says that that's surmountable and that they actually have a lot of really great partners in the West. And the biggest challenge is the plague. So plague is, when I say plague, I am in fact talking about the plague that devastated medieval Europe. It is the same bacteria in rodents and other wildlife. It is called sylvatic plague, and it's actually native to Central Asia and was brought to North America by people around the turn of the century. So what we think happened was around 1900, black rats that were stowed away on ships got off at the harbor in San Francisco, and they spread the plague to ground squirrels in California, which spread the plague further until it reached prairie dog colonies. Now, plague is not a big issue for humans today because of modern medicine and modern sanitation, but it can be really devastating for our wildlife, and it's a disease that really thrives with densely packed populations. And so prairie dog colonies are really ideal for this bacteria to really take root. So since the 1900s, plague has been spreading further and further east, but for a while it had actually stalled at the border with South Dakota. Scientists still don't really know why that happened, but in 2008, it hopped that border And there was actually one captive release site that was located in South Dakota of black-footed ferrets that had not yet been impacted by plague. And so there was the opportunity to see what happened to a very healthy population once it was introduced to plague on the landscape. And I wrote about that instance in my thesis, and so I'm going to do another short reading about that moment in 2008. The first sign that the killer had arrived in Kanata Basin was an eerie stillness. It was a crisp spring day on May 12, 2008, when a group of Forest Service biologists in Kanata Basin, South Dakota, noticed something was amiss. They were gearing up for a day of field work, installing a cattle-proof fence around a portion of Kanata Basin's expansive prairie dog colonies. Overlapping with Badlands National Park, the basin and its prairie dog colonies provide food and shelter to a dizzying array of wildlife. Fennec foxes, ground squirrels, burrowing owls, mountain plovers, and the park's pride and joy, black-footed ferrets, depend on the underground cities for survival. But on this particular day, not a creature stirred. No prairie dogs peeked from burrows or squeaked their signature alarm calls. Upon examination, the biologists noticed with mounting concern that the tunnel openings were caved in, covered with cobwebs, derelict with disuse. They were fencing in a ghost town. That's usually how it happens, says Travis Lavieri, a field biologist who's worked on black-footed ferret conservation for over 25 years. All of a sudden, one day, all the prairie dogs are gone. The researchers abandoned the fence and scoured the landscape until they found what they were looking for: a single dead prairie dog lying out in the open, untouched by predators. Alarmed, they bagged it up and FedExed the dead body to the Center for Disease Control for testing. They had to act fast. Once present on a landscape, the bacterial culprit they suspected could whip through prairie dog colonies like wildfire, killing nearly 100% of its victims. The test results came back within 24 hours, positive. The plague had arrived in Kanata Basin. The vanished prairie dog spelled disaster for Kanata Basin's 350 black-footed ferrets, then the largest wild population of the species anywhere in the world. Black-footed ferrets are one of North America's most endangered mammals and rely almost exclusively on prairie dogs for room and board. They were reintroduced to South Dakota in 1997, and Kanata Basin had become the gold standard reintroduction site for one increasingly obvious reason. It was the only site within the ferret's old range that wasn't already infected with plague. In 2013, after years of intensive dusting efforts and vaccinations, Kanata Basin's population of 350 black-footed ferrets had whittled down to just 50. Today, after over a decade of intensive management, the ferret population has crept up to just 100 individuals. So fighting disease is very difficult at the best of times because it's very hard to fight an enemy that you can't see. And plague is particularly and frustratingly good at hiding. So this is for a number of reasons. It's very complicated. It can infect a wide variety of species. And it's also really hard to detect even when you know it's there. Biologists have tested fleas and prairie dogs for plague when they know that it's on the landscape and have not been able to find it. And so often the best way to know that plague is there is that suddenly all of your prairie dogs are dead. So the best way of fighting plague right now is just mitigating the damage that it causes. So these pictures all represent sort of different ways that biologists do this in the field. So that middle picture is Travis Lavieri, who I quoted in the previous passage. He's spent most of his career working with black-footed ferrets in Kanata Basin. And he personally goes out every single year and captures all of the new kits each season and vaccinates them with a plague vaccine that was actually adapted from a vaccine used by the US Army, which is obviously extremely time intensive. He becomes nocturnal for like 2 months every year, but there are very committed people like Travis who do this every year. Another way of mitigating plague is to try to target the fleas directly that spread it. So that is done by going out on four-wheelers, like the one in the picture, and sticking a tube down every single prairie dog burrow and coating the burrows with a dusting of an insecticide called deltamethrin. And they call this delta dust. This is super effective, but also extremely time consuming, especially somewhere like Kanata Basin, which can have like 500,000 prairie dog burrows. It's crazy. So another mitigation technique that's still under development is trying to vaccinate the prairie dogs. And as you can see, that happy prairie dog in the picture is actually holding a plague vaccine. That is a peanut butter flavored pellet that they are starting to roll out and test in some release sites. And they are even testing using ATVs or using drones to sort of shoot those out where the prairie dogs will find them and eat them, which is sort of a less time consuming way of vaccinating, but also, you know, not ideal. So that's the situation as it stands right now. Black-footed ferrets are not going to go extinct anytime soon, thanks to the success of the captive breeding efforts and efforts of people like Travis Leveri. There are also some kind of long shot solutions in the works. There's an organization called Revive and Restore that thinks it might be possible someday to genetically modify black-footed ferrets to be plague resistant, because domestic ferrets, which are closely related, are actually resistant to the plague. And they're trying to isolate what makes them different from black-footed ferrets. But that's still quite a long way off. And for now, they are dependent on people who are really passionate about seeing them alive and well in their native habitat. And this year has posed obviously some added challenges for the program, and it's really managed to step up. And last I checked, the captive breeding facilities across the country have been able to produce over 200 new black-footed ferret kits this year. So yeah, that's it from me. Thanks so much for listening, and I can hand it over to Ashley.
Before we jump over to Ashley, Shannon, has Maura made it? Not yet. Okay. I think it looks like we probably don't have time for questions. Is that Shannon, is that your, yes, okay, no time for questions. Okay. And so who's introducing Ashley's thesis?
I am.
All right. And wait, before you start, Tom, as you're doing your presentation, if you can keep the chat open, that would be great in case there's any emergency broadcast messages that we need to send to you. We will do it there. Great. And Rachel, that was incredible. I'm very jealous. I've actually interacted with ferrets, and despite their very pungent smell, they are ridiculously cute animals. Yeah, I'm jealous that you got to go out and see them. But very well done. That was really nice.
Thanks.
Okay. So I was told to keep this extremely brief. 2 sentences was suggested. Just to say about the last thesis, Rachel, you missed my favorite ferret fact, which was that Rudy Giuliani had a complete hatred for them. And you know, that's always been a recommendation for ferrets in my book. But to Ashley, Ashley was the advisee that every advisor wants. She picked a fascinating topic. She developed a really smart research plan. She executed it, and then she wrote and rewrote through the process of refining her argument and her understanding in a way that I found fascinating. I learned so much from both the content and watching her work. And I think everyone who hears about what she's going to tell us in just a second will be really enthralled by what they're about to learn. And the one thing I will say that was so impressive about this thesis is it was what you want from a longer piece of work. It told a really good story about a specific problem, but it was always about much more than the story itself. And particularly for long form writing, that's the holy grail, and that's what Ashley achieved. So because she's going to tell the story and I'm not, over to Ashley. Come and show us what you got.
Thanks, Tom. It was the best, obviously, getting to work with you, and I'll say more on that later. But I, too, have a slideshow. You get to see some pictures, so bear with me. Okay, so my thesis story is about the plight of the Sonoran pronghorn, which is an endangered species that some reports say is the animal most threatened by increased human activity at the US-Mexico border. Where the Desert Ghost Roams explains how the near extinction of the Sonoran pronghorn in 2002, which happened after the worst drought in Southwest Arizona history, left only 21 animals in the US total, all of them living in this small desert area in Southwest Arizona. That occurred the same year that the number of agents at the border surpassed 10,000, then quickly over time doubled as more checkpoints were being added to the border following 9/11. So this flooding of the border with agents actually diverted the flow of migrants so that the majority of them actually entered the country through pronghorn country, making this small rural chunk of Southwest Arizona one of the Border Patrol's most active regions with the highest agent staffing demands. So the story kind of shows how these biologists, who at first were tasked with spending millions on doing stuff like building artificial water holes, land irrigation efforts, and other research to help the Sonoran pronghorn population rebound through these persistent drought conditions, they came to realize that the lack of water wasn't just because of drought. So they needed to invest in understanding more about the impact of this increased human activity, as Border Patrol was kind of draining irreplaceable water, permanently killing off plants through illegal off-road driving, and keeping the pronghorn in a state of constant fear of humans approaching. So what happened was that pronghorns were just spending so much time trying to like detect vehicles on these roads that just crisscross through their territory. If you look at the map, the only area that these agents weren't driving is where the mountains are. So, and pronghorns don't go into the mountains. So where the roads are is where the pronghorns are. Anyway, these biologists, they figured out, you know, they couldn't control the drought, but they thought maybe they could try to work with the humans, or so they hoped, you know. So they asked Border Patrol to get on board as an official partner on the Sonoran pronghorn recovery team. And so I wanted to explore how successful that partnership could possibly be in light of protests and lawsuits over Border Patrol's kind of lack of environmental stewardship, despite the Department of Homeland Security kind of boasting about this commitment to protecting natural and cultural resources, which is supposed to include wildlife. The story kind of exposes how projects like the Sonoran pronghorn recovery plan suffer prolonged neglect while Border Patrol kind of hides behind the partnership as proof of this supposed environmental stewardship. And the story, actually, this idea for it came up during a class assignment where our instructor, Tim, he asked us to prep for an interview with someone else in the class on a subject that they were an expert in, but like that we knew nothing about. And I got paired with Rachel, who had just visited the Sonoran Desert. And it was like, in the 10 minutes it took me to prepare for my interview with her, it was clear that I had just like stumbled into this world that I couldn't stop looking at. And so I've joked a lot that like I went to grad school to discover that I love antelope, but like the truth is that I'm just curious about the natural world. And because of that, I'm kind of protective of it. I think because there's just so many places that I haven't seen. So I went to Arizona for the first time, and I got to see the Sonoran pronghorn as my field experience, which, as Rachel said, you know, that was just such an amazing thing that I'm so glad we all, those of us who did, got to experience. So I drove through an active bombing range where I learned the pronghorn actually prefer to graze. And I got to see native lands where the pronghorn are kind of culturally treasured, but they're cut off from accessing by the major roads that I was driving around on, you know. And I found myself frequently stopping in Arizona, where there was like just this giant rest stop, and it was like the only rest stop in this tiny corner of Arizona. And if you look at this photo, I was very delighted to see that in this mural. If you look to the right of the Y, you can see someone painted a Sonoran pronghorn there. So of course I loved that. But if after this presentation, you're interested in trying to see Sonoran pronghorn in the wild, I wish you good luck. It's kind of impossible, but if you want to try, you can rent a truck and you can actually visit this green patch of irrigated land that biologists tend in Charlie Bell Pass. It's sort of a pronghorn sanctuary. I call it a rest stop in my thesis. But what I want you to notice now is you can actually see the grass. It doesn't even really look like desert. The rest of the desert is definitely not that green. But on my first day in Arizona, I visited the captive breeding pen at Cabeza Prieta National Wildlife Refuge. And I woke up in the middle of the night to drive into the desert for the first time before dawn. So I got to see this beautiful sunrise. And this was, you know, an unusual way to first encounter the desert, riding along in a biologist truck and, you know, seeing a part of the desert that's closed off to the public. And I kind of wanted to mirror that in the lead that I wrote, that experience of being a passenger. So what I'm gonna read for you now is my lead. 1,000 feet above the Sonoran Desert, a fixed wing plane circles. John Herbert is a passenger inside, looking down on an unusual patch of land in southwest Arizona, a small chunk of the most biodiverse desert on Earth, home to hundreds of animal species, thousands of plants. A biologist with the Arizona Game and Fish Department, he's been taking these flights weekly since the mid-1990s. He says the ride gets bumpy when it's windy, and the spinning can play tricks on the ear, but he likes the flights. It's a cool way to see the desert, he says. He's gone up hundreds of times, but he says every flight shows him something new. Each week, Herbert sees things most people never see, and he spends most of his time chasing a mysterious animal. Most Americans know that old Western anthem that goes, "Home, home on the range, where the deer and the antelope play." Well, there are no antelope in the United States. The American antelope referred to in the song are actually pronghorns. These exotic looking creatures with forked horns have been a fixture on Prairie since prehistoric times. About the size of a goat, but with eyes as big as an elephant's, they can sprint to speeds up to 60 miles per hour. That makes them North America's fastest land mammal. Herbert tracks a very special pronghorn, one uniquely adapted to live in the desert. Because its survival depends on this harsh and at-risk landscape, the Sonoran pronghorn is the only subspecies of American pronghorn that is endangered. Over more than 30 years tracking pronghorns, Herbert has been trying to answer a critical question. How do they survive there? He goes up in the plane to find out. Because the pronghorn herds move fast, he has to be quick to catch important details before they disappear, like what they're eating or what they're doing, or even which individuals are where. These delicate, elusive ungulates more than earn their nickname, the desert ghost. So, sorry, I need a water. The rest of the story kind of takes you through the rest of my trip. That's the structure of it. So I went and I met Arizona game and fish biologist John Herver in the Yuma office, which he assured me that he never visits otherwise. I drove to Tucson to meet with the No More Deaths media coordinator, Paige Korch-Clem, who sort of told me about where exactly the harshest regions were to travel through, and directed me so that I could visit those regions. And I also interviewed former Border Patrol agent Francisco Cantu, who was able to fill in a lot of holes after Border Patrol kind of predictably declined to comment. But I spent the most time with a fish and wildlife biologist, Stephanie Dories, who was so nice. She was nice enough to spend the entire day with me, driving around the desert, answering all my questions. And she also loaned me a spotting scope, and she showed me how to spot a Sonoran pronghorn herd in the wild. And that's a lesson that I kind of want to share with you now. So if you look in the right-hand corner of the screen, the Sonoran pronghorns have these white tails, round white circles. And what she told me to do was look for the round white rumps. So stare into the photo until you see white. And then once you see the white, you can kind of make out the forms, and you kind of just experienced what I experienced the first moment that I spotted them, which was extremely thrilling after traveling all that way. Actually, I wanted to clarify really quick for no real reason other than I was interested, but what they're eating down there isn't the alfalfa that you see baled up in that picture in the right, but the tiny shoots of grass that you can barely see in the desert, which if you compare looks very different from the desert grass that we saw in Charlie Bell Pass a few slides ago. That was the irrigated land. So here you can kind of see like the dramatic difference between those two pieces of land. But the grass, even though the pronghorn like to eat it, isn't their main way of hydrating. These thorny cactus fruits are one of their main sources of water, and they just look so cool. I found myself taking pictures of every single chain fruit cholla that I saw because they were each just like bigger and heavier than the last. So I want to say thanks to a lot of people, but especially to my thesis advisor, Tom, who actually knew who Edward Abbey was when I needed someone to talk to. When I first discovered Abbey wrote this amazing book called Desert Solitaire, and when I was trying to figure out how to write about the desert and really have a sense of setting, it was crucial. And I just couldn't believe it when Tom actually had like a very personal story about Edward Abbey. And it stands out as a moment of just like being paired with the right advisor. So thanks to Tom, and also thanks to everyone whose input, you know, I continue to value so much. So what I'm gonna read for you guys next is, it actually was my original lead. I almost threw it out entirely, but then as Tom kind of mentioned before, I got some outside counsel. My gastropod mentors, Cynthia Graber and Nikki Twilley, they both took time to help me restructure my whole story at the last minute. And, you know, I realized that it made more sense to me to leave the reader with this image, which is the image that kind of haunted me most and comes to mind first when I think of the desert ghost. And all you really need to know to understand the significance of this final scene is that if the pronghorn fawns don't survive, the whole herd doesn't grow, which, you know, another drought could easily knock out young adults before they have a chance to breed, which then leads to possibly eliminating the entire subspecies, which is a real threat basically any summer that gets too hot. If you look at the population data, they went from 250, which is more than they are now, to 21 in 4 summers. And every summer gets hotter. And in case you're wondering, they say next summer is going to be a hot one. So here, this is the conclusion to my thesis. A newborn fawn is too weak and slow to navigate the desert. Instead, it spends the first 4 to 12 weeks of its life nursing from its mother to survive temperatures above 100 degrees Fahrenheit. After the fawn's meal, the doe scrubs her baby until it's scentless. Then, in the most intimate maternal act, she lowers her jaw and ingests the fawn's feces and urine. She must leave no trace if she wants her fawn to survive, because her very next move is abandoning the fawn for hours. Hidden in dense shrubs alone, the fawn cowers, camouflaging its body against the matching sand. Dory says she read, you could almost step on the fawn and it wouldn't move. Foraging for two, the doe never forgets her fawn. She remains in a state of heightened vigilance as she grazes, ever aware of predators and humans approaching her baby. When she has time and space to focus, she nibbles leaves off spiky ocotillo trees, gulps prickly cactus fruit, roots out strands of desert grass. She spends all spring and summer like this, bobbing along, lowering her head to graze, then raising her eyes to detect threats at great distances. This distracts her from eating and shrinks her midsection until she looks like a walking puckered cactus, complete with thorns sticking out her sunken face. After she's eaten, she returns, appearing like clockwork every 3 hours. Most times, the fawn is so relieved to see her, it leaps to its feet and hurls itself at her, ready to feed. Other times, the fawn is gone, not because she lost it, but because despite her effort, she wasn't vigilant enough and it was snatched by a predator. When this happens, the doe is so distressed that even if she sees her dead fawn, she'll return to the same spot at dusk for the next 2 days, grieved and famished, scanning and calling for her missing baby. Stakes are high in a desert rattled by climate change, where the rain refuses to fall and increased human activity sucks out groundwater, stamps out a good chunk of the remaining plant life. So far, ongoing efforts have been enough to ensure that the desert ghost continues roaming Southwest Arizona, which has been Herbert's priority since he first heard of the Sonoran pronghorn, sustaining the numbers. As the desert gets drier, Doris pays closer attention to the impact of human activity, and Herbert keeps count of pronghorns from the plain. Despite the recovery team's achievements, survival of the Sonoran pronghorn depends on conditions of its range, where scarce rains make raising a fawn in summer a real struggle for a mother doe doing her part to grow the whole herd, Herbert says. If she can't feed the fawn, it simply starves. So I know that's sad, and so I'm gonna leave you actually with a different final image. Here you can see that I got very wrapped up in the Sonoran pronghorn story, so much so that I hand-stitched these pronghorn patches as a little tribute. I hope when people read the story that they start feeling pronghorn feelings too. Thanks, everyone.
Thank you so much. Those are incredible. That was a wonderful, wonderful story. And again, just hearing about all of the travel that everyone did is bittersweet. It's wonderful to hear about your research, and it's also difficult to think of how much the world has changed since then. I think Kate is next. And who is Kate's thesis advisor? Is that Alan? All right, you need to unmute yourself, Alan.
Do.
There you go.
Am I unmuted now? Okay. Hi, Kate. Well, Kate wrote and researched the search for extraterrestrial life. And she made the important point that most likely our first contact is going to be, or first discovery of extraterrestrial life will be biochemical rather than little green men landing on the planet. She interviewed a wide range of people at the frontiers of research and the search for extraterrestrial life. And a couple of the qualities that I most admire about Kate, she's very imaginative and creative, and she also is fiercely independent. So on to you, Kate.
Thank you, Alan. So I was up late on deadline, and I don't have any slides. And so I'm just going to riff here, and I just want to formally apologize to Alan and leadership at GPSW, and also my family for how this is going to go. But yeah, like Alan said, I researched the search for extraterrestrial life, and I got interested in it because I had just kind of assumed that what that would mean is that, like, eventually people would make a telescope that had like a thick enough lens or something that would make it so that they could actually just look with their eyes at a planet far away, and that they would just kind of be able to see a city on it, sort of, and that's kind of what that was. And kind of being at MIT and starting to kind of like poke around in astrobiology and space research, I discovered that that's not at all what it is, and that actually, like, kind of the entire project of looking for extraterrestrial life is really inference driven, and people have to make just a stack of assumptions. And so I think that I will start by reading kind of the intro passage of my thesis, and then I'll talk about that a little bit more, and then I'll read another passage. So here we go. We stand on a great threshold in the human history of space exploration, wrote MIT astrophysicist Sarah Seeger in testimony delivered to the U.S. House Committee on Science, Space, and Technology on December 4th, 2013. If life is prevalent in our neighborhood of the galaxy, it is within our resources and technological reach to be the first generation in human history to finally cross this threshold and to learn if there is life of any kind beyond Earth. Looking for a sign. Curiosity, NASA's planetary rover, has traversed the Martian landscape for roughly 8 years. Its venture represents one of the highest technological efforts of its time. But now its top-notch innards, pristine and golden in NASA laboratory stock photos, are obscured by a dusty and travel-worn exterior, hearkening to some Star Wars universe droid technology. Moving deliberately, turning, sampling, warming up an instrument for analysis, Curiosity follows the transmitted instructions encoded by an operator on Earth millions of miles away. When launched in 2011, Curiosity's nominal mission was to analyze the Martian atmosphere, soil, and rocks in an attempt to determine whether Mars has or has ever had environmental conditions required to support life. Not long after the rover landed on the Martian surface, it found small eroded stones, like those tumbled smooth in waterways on Earth. This discovery reinforced observations made by the Mariner 9 satellite in 1971 of what appeared to be riverbeds. Then Curiosity discovered organic molecules, those that assembled correctly, quicken, and live. Melissa Traynor, a researcher at NASA Goddard Space Flight Center, has worked on the Curiosity mission since 2009 and uses Curiosity's instrumentation to learn about the Martian atmosphere. What we're really searching for now is not actually life, at least on other planets, says Traynor. The current state of the art, so to speak, is actually looking for the chemistry that we think is related to life. And that was, that was a comment that she made to me when I was at a conference, like the Origins of Life conference that was in Texas before the pandemic, when I went to conferences. It was fun. And that, that really grabbed me, is that kind of at the end of the day, they're kind of just trying to pick out oxygen and hydrogen molecules and in these different atmospheres of these planets that they, can barely see, and kind of piece together a narrative about those planets. And so there's this difference, like when they're looking for life on exoplanets, which are planets that are outside of our solar system, where in an ideal world, they would be able to direct image them, which would be the thing where they're kind of looking through a telescope and can actually see them. But that's kind of the dream. There's I think that they've been able to do that with 12 planets outside of our solar system total of the thousands they've discovered. And instead, what they're doing is that they're waiting for planets to pass between the planet's star and the Earth, so that the light of the star gets dimmed momentarily, and then brightens again. And that's how they even know that a planet's there. And then they look at the way that the light is refracted through the atmosphere of that planet as it hits the Earth. And then they kind of try to unpack what must be in that atmosphere to refract the light in that way. And then next, once they have a sense of what might be in that atmosphere, then they're trying to decide what might be going on in the planet that would create those kinds of conditions in the atmosphere. And whether that is a living system or just some kind of just physical chemistry that might be playing out. And then if they were to decide that there's a living system, then they would be interested in like, what might that be? Is it just microbes that are making like oxygen or CO2? Could it be a civilization like ours that would maybe be releasing some kind of like some equivalent of our greenhouse gases into the atmosphere, or some kind of pollution that we could detect in a certain way? And at the end of the day, they might just not ever know what the answer to that question is. They might just discover a planet where they don't have a really good explanation for what's happening in the atmosphere. Like they can't come up with a thing that it would be that isn't life, but that would be all they have. And so I'll read a passage now that's about a discovery that they made on Mars that kind of has some of these themes. And I think it's also telling that Mars is a place where we can actually get eyes on it. Probably at some point people will be able to go there. We've sent, you know, like Curiosity and other rover missions there, and presumably they could bring stuff back. They have an actual video camera where they could look around. And even in that context, they're really not clear about what's going on in Mars. And so then to try to extrapolate that to a planet that's, you know, trillions of miles away, where all they have is flickering starlight to try to figure out what's going on. Curiosity sends landscape images of the surface of Mars. They are oddly familiar: cliffs, mountains, rocks, broad desert plains. They could almost have been taken on Earth, maybe in the Badlands of South Dakota or the desert mountains in Nevada, but their provenance is betrayed by the absence of anything obviously alive. There is not one scorched plant. With notable exceptions, when modern scientists talk about finding life on Mars, they are talking about finding evidence of past extinct life. Curiosity was sent to investigate ancient Martian environmental and climate features. The NASA Perseverance rover, which launched in summer 2020, will follow up on Curiosity's work, looking for evidence of ancient life itself, perhaps microbial fossils or leftover chemical signatures. However, using Curiosity's onboard instruments, Trainer's team discovered something extant and odd: an unexplained seasonal fluctuation in atmospheric oxygen and methane levels. Methane and oxygen are both considered potential biosignatures, a chemical or phenomenological sign of life. On Earth, both methane and oxygen are produced in abundance by living organisms, but can also be generated through non-living processes. Regardless, researchers hypothesize that a seasonal chemical fluctuation detected in an atmosphere could itself be a biosignature, even if the fluctuating gas was not oxygen or methane. For instance, carbon dioxide, which is easily produced by both living and non-living processes, fluctuates seasonally on Earth because of plant respiration. During summer in the northern hemisphere, plants' consumption of CO2 increases as they build biomass and decreases in the winter as plants die or go dormant. Subsequently, CO2 levels in the northern hemisphere decrease in the summer and increase in the winter. Trainer says seasonal fluctuation on Mars could be driven by non-living chemical processes. Seasonal changes in temperature, relative humidity, airborne dust, and ultraviolet radiation could be altering Martian atmospheric chemistry. The thing is that with the measurements we have of those parameters, nothing is tightly correlated, said Trainer. Could it be life? Hardy alien microbes persisting in the soil, rocks, or deeper underground? That's what makes it kind of intriguing, It's a question we always have when we find something unusual, says Trainer. But as responsible scientists, that is the explanation of last resort. I would want to go through every single possible other explanation. It's very clear there's a lot more going on Mars than we can currently understand. And that same situation or similar situation actually just maybe, I don't know, like 4 or 5 weeks after my thesis was due is playing out on Venus right now as well. Like they found a biosignature in the Venusian atmosphere. It's a gas called phosphine. And on Earth, that gas is produced only by living creatures. Either bacteria make it and also humans make it in labs. It's poisonous. I think humans made it to poison people in war. Don't quote me on that. But other creatures just make it. It comes out of swamps and it's a thing. And they had actually before discovering it on Venus, they had done a ton of research to kind of rule out non-living processes that could make it. Like, can lightning strike a rock and that makes it, or can like the ocean be interacting with some soil somewhere and that makes it, something like that. And they had already kind of been like, oh, we think phosphine is a thing that we could look out for in the universe and maybe detect life that way. And then they detected it in the atmosphere of Venus. And Venus is kind of known for being like a boiling hellscape. But there's a cloud layer that's made out of acid.
Sulfuric.
Acid. Thank you. It's made of sulfuric acid, right? Which is not a place we think of us wanting to live, but it's sulfuric acid that has a little bit of water dissolved inside of it, and it's relatively temperate up there. Like the temperature fluctuation is sort of similar to what we as humans experience in our day-to-day lives. And so they're looking at that cloud layer and they're being like, could there be critters in there that are surviving, and these like tiny little water droplets dissolved inside of sulfuric acid? And then that cloud layer is where they found the phosphine. And so everyone's really excited. And, you know, as kind of a microcosm of this whole issue, there's another piece too where, you know, what they have is some like light moving through the atmosphere or something like that, and refracted light is how they made this phosphine detection. And so there's also this additional question of, did they even find phosphine there before even the question of, does the phosphine mean life? But Venus is a planet where we actually can just like cruise something through that atmosphere and scoop things up and bring it back here and like look at it, which has its own like kind of weird ethical questions that people in this field talk about, is like cross-planetary contamination and what's going to happen if we like scoop up like a microbe in the Venusian atmosphere, bring it here, like that kind of stuff. And that was another piece of what I found to be so fun and interesting about this research project, is a lot of stuff that is really sci-fi and is the kind of thing that I think of like kind of like tinfoil hat kind of aliens, like people, you know, being like talking about are actually kind of real things that like real kind of philosophers of science like kind of address. Like, is it ethical for us to go look at Mars when we might be colonizing Mars with our microbes, and like what's going to happen if some microbe comes back here? So, oh, my overtime, amazing. So I'm getting a message that I'm over time, which I'm very excited about. So yeah, I can just wrap it up there. Cheers.
Thank you so much, Kate. I think you would have had the farthest thesis travel for yours if you had managed to travel. I think we're going to take about a 7-minute break so people can stretch and use the facilities if they need to. No reports necessary afterwards. And you can leave it, you don't need to sign out and sign back on. You can stay here, but we will reconvene now in 6 minutes at 11:15. So see everyone soon. And
I'm here if you want.
Oh.
Welcome back, everyone. And again, our participant count is going up, so that's good. We're not shedding viewers, we're gaining viewers. So we have about another 45 minutes of presentations, 3 more presentations, and then we will do a brief virtual graduation ceremony. Then we'll conclude the events. And again, thank you everyone who is joining us. It means a lot to us that we can celebrate with this year's class. And I know it means a lot to them that there are people able to be here even in this extraordinary situation. So without further ado, I'll hand it over to Tom.
Thank you, Seth. And thank you, again, this is about Jessie, and I want to make sure Jessie does most of the heavy lifting. But I also want to thank Shannon and all our colleagues in this program, because I think everybody knows this was a very interesting year in all the full sense of it. Shannon had to do an enormous amount of behind the scenes heavy lifting to make everything possible, including this event. And Seth and Alan, as you know, the helming the program, also had extraordinary decisions and actions to take that no one anticipated. So I am, as an instructor in the program, really grateful that we were supported sufficiently to try and make as much as we could out of what was a very challenging year. Jessie I was very lucky in my advisor. Well, all our students are great. And working with them closely in the advisor role is always one of the real pleasures of the year. But Jessie is, you know, another one of those kinds of students who it's just, you know, endless fun to work with, because you know, her motivation in science writing and science communication is her own relentless, persistent, joyful curiosity. She discovers a topic that seems to her to be sort of more wonderful than people realize, and she is compelled on a deep and personal, emotional level, both to grasp what's the meat of that topic and to make sure that everyone around her knows just how cool and wonderful it is. And it's really fun to be around that, and you learn so much. One learns so much, and one, you know, discovers nooks and crannies, even of subjects that you know, and there are parts of Jessie's thesis topic around time and timekeeping that I thought I knew pretty well, and Jessie kept surprising me with new stuff that I didn't know. And it's this return to the pure pleasure, I think, of science communication, which is what gets a lot of us into this business. There's something really cool out there. Look, I can find out about it, and then I can tell people about it. So I had a great time working with Jessie. I learned a lot from her, which is what you always hope to do. And without further ado, Jessie, spread the love to everybody else.
Thank you, Tom. That was very generous of you. I think that, so I'm going to do this. I also, as well, kind of like Kate, did not have a super long time to prepare for this, but like Tom mentioned, I'm really excited to talk about this subject because I had no idea about the Biography of the Second, which is the name of my thesis. Tom taught me a lot about this subject, and I got to fly to England and go to France to research all of this. So I consider myself extremely lucky, and thanks to GPSW and everybody for making that happen. Thank you for everybody who showed up. A little bit of an embarrassing story, since I am going to be reading the beginning of my thesis, and the word time zone is in that very first paragraph there. When I invited everybody, I completely messed up the time zones from East Coast to West Coast, which was very fun. Oh, thank you, Huck. So to give a brief overview of the second, 1 second of time, it really starts 5,000 plus years ago, back with the Babylonians, who had this system of dividing up units. So it was I'm going to say this word wrong and everybody can giggle, sexagesimal. Tom, is that? Yep. So this is supposed to be entertaining as well, right? We're having fun. Dr. Sarah Schechter at the Harvard Museum of Instruments, she was explaining to me how the Babylonians divided up a unit into 60, right? So you have an hour, we divide that into minutia, which is where we get minutes. This is the fun fact part of my presentation. And then they divided those 60 minutes secondarily into 60 seconds. So that's where seconds come from. So if you take anything from this presentation of mine, you can all go tell your friends where the word second came from. And if it's wrong, we can blame it on Harvard. All right. So yeah, okay. So we start at Babylonia. Seconds didn't really even become important though until, I'm going to say, the 18th, 19th century. Forgive me, Tom, for not rereading my thesis before this. You all might have heard of Deva Sobel's longitude, and she tells the story of Harrison and his chronometer. And this was a time where, you know, before this, we have sundials, like we know when we have to go to dinner, we know when we have to go to work, but we don't really need to know time down to the second. But that all changed when the problem of longitude was created and ships were hitting rocks and losing cargo and losing lives. And so I'm gonna cut through a lot of the story, but basically say that this really amazing clock builder, Harrison, came up with this chronometer, the H4, that could tell time accurately at sea. The second was important. And then from there, I'm gonna jump to modern day because this chronometer was accurate to about, let's see, maybe like 1 second in 30, it was off every like 30 days or so. Jump 200 years later, and now scientists can be accurate to like 1 second might be off in like 100 billion years, or the length of the universe. And I'm making all of the people who know all of the real scientific numbers cringe here because I'm sort of paraphrasing. I'm now going to read the beginning of my thesis, and then I do have some pictures for you as well. I have a slide presentation, but here's my reading. I woke with a start at 6 a.m. to the sound of my alarm, although my body told me it was only midnight. Still jet-lagged from my journey from Boston to London, I was relieved that my phone always knew the proper time regardless of the time zone. Even thousands of years ago, people knew that time and location were connected. In the 18th century, sailors learned to determine their exact longitude at sea using marine clocks. Now, atomic clocks and satellites orbiting the Earth can pinpoint our location through our smartphones with exquisite accuracy, all thanks to the international standard of timekeeping, the second. Walking sleepily down the streets of Paddington, I didn't know yet that around 12,500 miles above me, there were atomic clocks in space beaming the correct time down to my phone. I stopped manually setting clocks a while ago, but I couldn't quite remember when the ritual ended. You guys remember when we used to call time? At the tone, the time will be something seconds. So I don't know when I stopped setting time, but this little thing came along and that all stopped. So I'm going to skip ahead and talk about, I had decided that the best way for me to get from Paris to Paris from London would be the Eurostar train, which requires traveling a little over 31 miles through a tunnel, the majority of which stretches beneath the English Channel. For weekly commuters, it was just another week. But for me, the thought of traveling under the weight of the English Channel was nothing short of terrifying. I don't know if you guys have ever done the Eurostar, but it is a little bit scary. The high-speed train can travel up to 186 miles per hour, but according to their site, Eurostar only travels 100 miles per hour while in the tunnel. So how long would I have to endure the anxiety of the tunnel? So I began my calculations. 100 miles per hour meant that we would travel 1.67 miles per minute. So after 18 and a half minutes, we would have covered the length of the 31-mile tunnel. It's a few blinks of an eye, the time it takes a hummingbird to flap its wings 80 times, for a photon of light to travel from Los Angeles to New York and back almost 40-fold, or 147 feet of traveling through the channel between London and Paris. The second has been there since the literal dawn of time, if one exists. But what defines the second? Like a pop star constantly reinventing themselves, think Lady Gaga, Madonna, the second has undertaken a myriad of identities, first defined as a brief moment in the daily rotation of the Earth around its axis. But today, the second is officially defined by over 9 billion oscillations of a cesium atom. Although it has changed costumes, its astronomical roots still ground the second. These definitions are identities projected onto it by an ever-curious, ever-demanding fan base. These fans are, of course, us, humans living in a complex, evolving society. They have been priests, farmers, scientists, but now whatever our relationship is to one tick of the second hand, we are now beholden to this new atomic second far beyond matters of time. So this is like the whole why of my thesis, right? So our entire technological infrastructure, from airplanes to smartphones, televisions to stock markets, driving directions to space research, all of this would crumble without the atomic second and the 21st century horologists that build the timekeepers of the modern second, the atomic clock. So I'm going to stop there because I'm going to show you my journey from England to Paris underneath the channel when I had to do that. That was all to go visit an atomic clock in person at the Paris Observatory. And I'm going to show you a little bit of that journey and what it looks like if I can figure out my screen sharing. Okay, I think I have to start my slideshow. Here is my title screen. A little anecdote. This right here is Tiki. Hi, I'm Tiki. So Tiki is sort of your Microsoft Word kind of, wow, we don't even use them anymore. The paperclip guys. And this is Fernanda originally came up with this idea. So thank you, Fernanda, for the fun times. And I threatened that my whole entire thesis was just going to be Tiki explaining time, but I decided not to. This is the beautiful Paris Observatory grounds, gorgeous little thing. And I describe in my thesis going down to see an atomic clock, but I figured I would show you the journey. So you have this really beautiful, beautiful grounds. And then you go into this like very like, you're like, oh, this is like this kind of like sketchy building, to be honest. It looks a little shady, but you go down and I'm like, okay, like I trust these scientists. Like they're not gonna, no, it's not gonna be weird. But it's a very precarious kind of place. So we're going down, you're going down even further down. Here's the hallway. And I thought, oh, here it is. Very clean laboratory. Here we are. We're just like we see in every Hollywood movie. We're going to walk into the laboratory and it's going to be this immaculate, amazing. This is what it looked like. So this is an atomic clock setup. This right here, if you look inside that little blue thing, that is one atom. So that is a strontium atom. I won't get into all the details of how it all works. This is H4. This is Harrison's chronometer. So this is what we usually think of when we think of a clock. So this was one of the first clocks that really told, that gave us the really high precision accuracy of a second. So, and this is what we know and love as a clock. And then this is yet another display of what our modern day atomic clocks look like. So maybe not what you might have pictured when you think atomic clock. So after this whole trip, I came back to MIT and bam, global pandemic hits. And 6 months later or so, we have a thesis, and I have finally gone through everything, gotten this out with Tom, made something happen. And at the same time, the entire world was discovering what I had discovered in my thesis, which is that time is a construct. So you really have all of these people talking about defining time, defining the second, defining our months, days, years, everything. it's all just kind of people deciding on this stuff. It's very, some of it is very arbitrary. So it's an interesting thing. So we have all found out that time is a construct. Nevertheless, thank you for your time in watching this presentation. I appreciate it. This has been a strange type of thesis day and graduation, but I really appreciate it, the opportunity to do it. So yeah, I'm gonna stop now.
Thank you so much. I miss Clippy. Clippy got a bad rap. So I think next up is Fernanda. Looks like she's in a very austere, elegant room. But to introduce her thesis, here is Tim, who's in the opposite of an austere, elegant room. You need to unmute yourself, Tim.
No, it's Alan.
I was Fernanda's advisor.
Oh, sorry. Oh, I had that wrong.
My fault, sorry.
If Tim is dying to introduce her, I'll cede the floor, but.
No, please, Alan.
Okay. Well, Fernanda came to me and told me that she wanted to do a thesis on high heels.
Yeah.
And I was absolutely appalled and outraged. Then when she began talking to me more about how she wanted to discuss high heels, I began to understand the brilliance of her idea, which was not only to trace the history of shoes and heels and fashion, but the aspect that interested me most and that she went into in her thesis was, why is it that people, and especially women mainly, wear high heels? Why do women wear an article of clothing that is so painful and that actually damages their body? And so she talked to doctors and documented the damage that high heels do to your feet. But then she explored the sociological pressures on women, all the reasons why women are willing to wear high heels when it is so painful to them, all the social issues involved with that. And I thought that was really a very, very interesting part of her thesis, which brought me in. Like Kate, she's independent. She's an independent thinker. She needed very little guidance from me. I think her thesis was probably turned in sooner than anybody else's, very, very much on time. So Fernanda, tell us, are you wearing high heels right now? Can I ask that question?
I am not. I haven't worn heels since March, so.
Okay. Well, Fernanda did recount in her thesis some of her personal experience with high heels. Anyway, on to you, Fernanda.
Perfect. Thank you, Alan, and thank you everyone for coming, either good afternoon or good morning, depending where you are. And like Alan said at that first meeting, when I left, when Alan was a little bit more convinced about the topic of heels, I asked him if anyone in GPSW had ever written about shoes before for their thesis, and he said no, it was completely new. So I'm really grateful that the program let me write about high heels and whether you can engineer a comfortable heel. It was really a pleasant surprise, because I think a lot of clothing is seen as a very fluffy topic, but the truth is every object has a long, long history behind it. And I was really happy to be able to explore that with heels. And actually, when I proposed this topic together with 3 others about a year ago, I put it in thinking it would never be picked, and it ended up being picked, so here we are. But if you're wondering why I chose heels, and is there any science behind them, I totally get it. And so to sort of start explaining that, I'm going to read the opening of my thesis. Okay. So in 1909, a woman fell out of her second-floor window. The culprit, the Chicago Daily Tribune blared, were high heels. Miss Philina B. Teal of Manhattan's Upper West Side was sitting by her open window when a breeze blew the lace curtains towards her. She stood up to kick them away, and as she did, the high heel of her slipper caught in the curtain. She lost her balance, toppled out of her apartment, and according to news reports, sustained severe bruises of the face and body, and internal injuries which may cause death. Teal was ultimately not killed by her high heels. She would go on to have many more years of wearing high heels, probably experiencing far more pedestrian kinds of high heel related injuries, such as bunions, hammer toes, and plantar fasciitis, which are way more common than her fluke accident. So common that doctors have been harping off and on about the dangers of high heels for almost 300 years. In 1872, London surgeon P. Hewlett turned to Scientific American to tell the story of a young lady whose heeled boots had injured her feet. Open quotes. I said, "It is simply heels versus brains. If you have brains, you will cut off the heels. If you have no brains, you will continue to wear them." The young lady, like all young ladies, had brains, and her feet issues disappeared when she did away with the heel. 46 years later, the French Académie de Médecine was forced to discuss the issue of high heels due to the prevalence of pairing them with the very short skirts that the women would have taken to wearing. That's about in the 1920s. And the Academy passed a resolution declaring that the fashion of very high heels was injurious and absurd. Despite the sexism-drenched warnings and condescension from the medical establishment, high heels have remained a staple in Western fashion since the 17th century. Even when heels fall out of fashion, they manage to return taller and more spindly. And with heels comes pain. Trying to remember when I became aware of the inevitability of pain when wearing heels is impossible. One is never without the other. And every time there's pain, such as a pulsing bunion after a day in Mary Jane's at a conference, or in the balls of the feet after a wedding, there are questions about why we live this way and whether there is a way to live pain-free, and if there is, whether we take it. So if I were to give sort of a one-word answer as to why I got interested in the topic of my thesis, it would be pain. I think like many people who have worn heels, I've experienced that sort of instant regret the day after a party when you can only gingerly walk around. And I've also made that strange choice of re-wearing the same heels at the next party. But I only wear heels pretty sporadically. The injuries that happen for sustained use of heels, which is sort of expected if not required for certain professions such as flight attendants, are significantly more painful. So to explore these, like Alan said, I read a ton of papers and spoke to foot surgeons and podiatrists. And I'm only gonna give sort of a short amount of it because it's kind of gruesome, but like gruesome in a fun way. So let's go. So because the body's entire weight is borne by our feet, these injuries extend beyond the foot itself, creating a painful chain reaction that hikes up the body. Picture a foot in a free-inch stiletto. The elevated heel position increases plantar flexion, where the foot points down like a ballerina dancing on point. The position forces the knee to compensate by adopting a slight bend that flexes the knee, leading to the spine to curve inward. Gait issues as well as back, shoulder, and neck pain result. The way your foot is shaped inside your shoe, you're forcing it into a position where it's not happy, explained Dr. Grace Torres Hodges, a podiatrist in Pensacola, Florida, who regularly sees patients with conditions associated with high heels. The more elevated the heel, the more one's foot is forced forward, pressing it against toe boxes too small to contain all 5 toes. This pressure is a disaster for those with a predisposition for hammer toes, bunions, and ingrown toenails. These aren't invisible issues. Ingrown toenails bend and start growing into the flesh, giving toes an inflamed pink coloring. Hammer toes, a deformity of the middle joint, gives toes a claw-like appearance, like a bird of prey ready to snatch its next meal. Bunions, a bony bump that pulses at the big toe joint, juts out red and angry. In extreme cases, all 3 can require surgery. When a patient arrives at Torres Hodges' podiatry clinic complaining of foot pain, she starts by locating the problem and trying to relieve the symptoms. But one thing I always mention with any kind of condition is it's all good and well to take care of the symptoms, she said, but if you don't get rid of what is causing it, it's not going to help you. This doesn't mean that Torres Hodges preaches completely eschewing heels. She wears them herself when she gives lectures. Instead, she preaches moderation. It's just like when you're talking to diabetics and tell them they can't have ice cream, she said, you can, just don't eat ice cream when you're having everything else. So that sort of explains why sort of pain and these injuries are sort of the driving force behind the question I asked in my thesis topic, which is whether we can engineer a pain-free high heel. But sort of, as Alan said, like the easiest way to live pain-free is to just not wear heels. And so one of the things, which is different from things like sort of like the breast pump, which is a necessary evil. And so one of the things he asked me to do, and I thought, and I think I pushed back at the beginning, but I do think it was important to ask, was to sort of see why if high heels are so uncomfortable and so painful, what are the forces, be they societal or cultural or psychological, that keep people wearing them? And so to explore that, I really went into the history of heels, and I was very lucky to get to talk to Elizabeth Semmelhack, who is the senior curator at the Bata Shoe Museum in Toronto. And she's just also a wonderful person and like the premier shoe historian out there. And I also got to speak to a lot of different women and other people who have written about shoes before, about why they wear heels. And I mean, there's so many reasons to go for it, and it's kind of hard to find a single value system because everyone has a different value system for it. So I just want to read two sort of accounts of why they wear heels by two women, one of which some of you might recognize. So I'll start now. Radha Sharaf, a research scientist at a cancer genomics company in Cambridge, Massachusetts, wears high heels because of the way they look, the way they make her look, but also for their ability to make her feel like an adult. Sharaf grew up watching her mother in heels, and as a kid was told she was too young for them. I always associated it with being grown up, said Sharaf. For her, heels have a second role thanks to their classic click-clack sound, heralding one's arrival. They announce that you're about to enter into a room, she said. It's like you have your own butler. And then the second person who talked about wearing heels and actually wore them at her PhD defense like I did, when science journalist Bethany Brookshire defended her PhD in physiology and pharmacology at Wake Forest University in 2010, she wore 4-inch high ankle booties with silver buttons up the side. They looked fantastic and they were really hard to walk in, and I did not care, she said. Brookshire was 5'10", and in the ankle booties, she was 6'2", taller than 4/5 of her defense committee. Brookshire explains that the shoes were chosen on purpose. It was glorious to tower over in my giant heels and look down at the white men judging my dissertation and be like, so did I pass? So I think there's a lot of reasons why people wear heels, and either for reasons of authority or femininity or confidence, or because you're going to a PhD defense. So the next question I had is, could we design a better heel, and who is doing that kind of stuff? So my last reading, I think I'm okay for time. Yeah, so my last reading will be from this section. It's going to be kind of choppy because I just chose different parts of it, but hopefully it will all make sense. So on one of the coldest days in New York City this past winter, I took the R train to Long Island City to try on shoes at the showroom of Antonia St. NY, a startup shoe company that launched with a Kickstarter campaign in July 2017. The campaign's title, High-Tech Heels and Flats That Feel Like Sneakers Inside, had all the taglines of the crowdfunding campaign: a universal problem, a techy solution, and an outrageous promise. Antonia St. NY isn't the first or last company to arrive on the market in the last few years promising to deliver comfortable heels. Many shoe companies promise comfort, but these startups and brands go further. They don't just promise comfort, they list their bona fides in their marketing, sprinkling the word tech throughout their website and drawing attention to their patented technologies. Knowledge of the anatomy of the foot and intimate awareness of the pain caused by heels are also there, as are origin stories involving uncomfortable heels. The idea of Antonia St. NY came to Antonia Dunbar in 2013 as she was walking to the headquarters of Thinks, the period-absorbing underwear of which Dunbar is a co-founder. I was down to one pair of shoes that I could wear that was cute enough and comfortable enough to get me through day and night, said Dunbar over the phone. At home were 100 pairs of shoes, none of which fit her needs. I wanted to be focused on the things I was saying and what I was trying to accomplish, and not on the pain in my feet, she added. In 2014, Dunbar started to sketch out the idea for a comfortable shoe, using many of the same questions that had driven the development of Thinks, such as how could the product be improved and what changes would you want to see? I really focused my shoe design on the pain points that I had, said Dunbar, pain points such as blisters on her big toes and support for her tall arches. The Antonia St. NY showroom is a long rectangle, one side dominated by shelves stacked with boxes of shoes, and the other by windows that look out onto the endless train tracks weaving into Manhattan. On the end of the room is an enlarged picture of pale gold sparkles, emblazoned with the question, how am I breaking the glass ceiling in 2020? No one had added their answer, but it was only the second week of January. So I did end up buying the shoes, and they were quite expensive because turns out comfort is expensive because it requires a lot more materials. And so the shoes were about $225, and I wore them for exactly 30 minutes back in March. And they were fine, but I think truth is, like, there is no such thing as a completely comfortable heel, but I really haven't given them a test drive because turns out, I think 5 days after that happened, MIT shut down and everything shut down. So they've been waiting in their box here for an actual test drive where I can wear them for a few hours instead of just 30 minutes. But basically, I think the, sort of in the long history that high heels have had, people have sort of guessed that they sort of rooted for their demise at different periods, and every time this demise seems to be coming, they resurge. And so I think the question is, will, if they resurrect, because they're currently in a demise now, will they be engineered for comfort? And if not, in the meantime, as we wait for a comfortable shoe, we'll just have to have backup shoes, because it turns out that's what it is. That's about it. Thank you.
Thank you so much. I don't deal well with descriptions of pain, but that was great. Yeah. I just am thinking about ingrown toenails and only inspired by heels. So our final thesis of the day is Lucy Jakub. And Lucy, it turns out that both Lucy and Rachel's advisors are not here for the same reason, because they are covering the situation with President Trump's COVID diagnosis. For the first time this year, ironically, is not the, it would only be ironic in the I'm blanking on her name, but whoever the singer was who had the song ironic use of the word. But we, this year for the first
Morissette.
Morissette, thank you. We actually had remote thesis advisors before the pandemic. And Lucy and Rachel were our two guinea pigs. And the reason we did that was because there were reporters and writers who seemed, that we knew, that seemed sort of uniquely suited to work with them and their topics. And afterwards, I did postmortems with both the students and the advisors. The advisors were almost overly effusive in their description of what it was like to work with Lucy and Rachel, and are both incredibly busy. Rachel's advisor writes often for the New Yorker. Lucy's advisor is a reporter for the New York Times, a science reporter for the New York Times. But we're incredibly eager to work with our students again, which I think is an incredible testament to the work that the two of you were able to produce. So without further, yes, and their advisors are, Shannon just reminded me, I should say their names. Their advisors are Apoorva Mandavili is Lucy's advisor, and Maura O'Connor is Rachel's advisor. So you can look for their bylines on your favorite news organizations. So without further ado, we will move on to Lucy, our final thesis presentation of the day, and then we will have our short graduation ceremony. So take it away, Lucy.
Hi, thank you, family and friends, for being here. I rely on Apoorva to tell me what is going on in this crazy year. So I'm glad that she's out there doing her job, and she was a great advisor. So I do have a few slides that are just nice pictures of the Gulf of Maine to put you in the mood. So I'm going to share my screen and set this up. I've never shared my screen on Zoom before, so this may take a minute.
Ashley, maybe you could sing Home on the Range again.
It's the green share screen button. It should be on the bottom of your video, and then you just choose which of your desktop things.
It's actually something about my privacy preferences. Well, here, let's try it now. Okay, yes, great. So my thesis is on climate change in the Gulf of Maine, and this was a sort of personal thesis for me in some ways because I am from Maine and I grew up in a town on the coast of Maine that has a large fishing community and an economy that's very much tied to the ocean. But in Maine, along the coast, there are sort of two classes of people, like those who make their living from the ocean in some way, either as fishermen or people who study the ocean, or people who are involved in Maine's economic management. And then there's everybody else who enjoys walking along the rocky coast, but has no idea what actually happens in the Gulf. So I set out to educate myself about this place that I love, but also to find a way to write about climate change in the Gulf for people who are not intimately connected with. And what I learned is that even the people who fish in the Gulf and study the Gulf have very often contradictory views of what is happening there and what the future looks like. So climate change in the Gulf of Maine is a story that really, people started reporting on it seriously in 2012 and then in 2015. 2012 was the year that Hurricane Sandy devastated New York, but it was also, as that was happening, there was a marine heat wave that entered the Gulf of Maine, and there were some pretty remarkable changes that happened that year that sort of caught the attention of the scientific community and the government. And one of those things was that lobster had a boom year. There were, instead of lobster molting only once over the summer, the lobster in the Gulf molted twice, which, because of the way lobster is regulated, meant that fishermen could harvest twice as many lobster. And this was something that had really interesting economic repercussions, but also sort of brought to the fore this anxiety in Maine about what the future of the lobster fishery looks like and what could happen if the Gulf gets too warm for lobster, which is currently constitutes most of Maine's marine resource value. So of all of the things fished in the Gulf of Maine, lobster accounts for 3/4 of the value of marine resources. And in 2016, that was almost $2 billion at the dock. And then several more billion if you think about sales in restaurants and the tourism value. So it would be pretty devastating for Maine to lose that fishery or for it to become less productive. And so much of the talk about climate change in the Gulf of Maine has to do with lobster and the temperatures that lobster are able to tolerate. So I'm going to start at the beginning of my thesis with an introduction to a lobsterman that I met in Stonington, Larry Moffat. So I'll start reading. And here is a map of the Gulf of Maine for you to look at while I do that. Larry Moffat is selling his boat, a white 36-footer with aquamarine trim. He has captained it for 2 decades, the 5th boat of his lobstering career. He couldn't find a stern man to hire last season, a business proposition that's always been a sure thing in Stonington, Maine's lobstering capital. Bait prices have been wickedly high. 2019 was a dismal year for herring, and lobstermen have been obliged to load their traps with rockfish flown in frozen from British Columbia and rosefish from as far away as Uruguay. The profit margin for lobstering, fat just 6 or 7 years ago, has been whittled razor thin. Moffat knows that if his 300 horsepower engine were to fail, he couldn't afford to replace it. I can't quite wrap my head around it, he tells me, confronting his retirement. In some ways, it's a relief. It's a greater relief to his daughter, Lydia. It is dangerous for anyone to go out on the water alone, especially an old man of 70. Lydia once employed me for a summer washing dishes in her bakery, but this is the first time I'm meeting her father. He's very tall, wearing house clogs and checkered flannel. His face is long and creased, framed by lank hair that's still dark. I've seen his oil paintings of light-filled seascapes hanging around town. We were sitting in the timber frame house he and his wife built in the woods, brick red on the outside, clean and raw on the inside. It is not unusual for a lobsterman to have several trades. It's important to have insurance against the unpredictable. Around here, there are many ways for life to feed you. Mostly, though, it's been lobster. Every season, Mainers wait to see if the lobster fishery finally reverses its wondrous growth, which has been a salutary effect of a warming ocean. Starting in the 1990s, American lobster, in a portentous migration, abandoned the fishing grounds of Massachusetts, Connecticut, and Rhode Island, and began to settle in the Gulf of Maine. This move had devastating consequences for the lobster strongholds of southern New England, but it was an economic boon for the fishermen in Maine who had recently watched their longtime livelihood, Atlantic cod, collapse and fail to recover. All along the coast, lobster has brought a heady influx of cash to small towns. Fishermen bought big, tricked-out boats, and rumor had it that if a young man brought his lobstering permit to the bank, they'd loan him anything. Lobster now accounts for 3/4 of the value of Maine's marine resources. In 2016, that was $1.67 billion at the dock. Now I'm going to introduce you to the Gulf of Maine itself, which is, many of you may live along it in Massachusetts or in northern New England, but it's important to understand how Maine, the Gulf of Maine, is its own body of water in the North Atlantic, and is experiencing climate change in a very unique way because it is separate from the entire North Atlantic. So in 2015, there was, after the hot year of 2012, scientists sort of analyzed many of the trends that had come out of that hot year and noticed that the Gulf of Maine, the surface temperatures in the Gulf of Maine were warming at a faster rate than 99.9% of the entire world ocean, which was a really shocking figure. And it brought a lot of people's attention to the Gulf of Maine and what's going on there. And people began to sort of treat it as this sort of the vanguard of climate change in the ocean and this glimpse of the future of this warmer global ocean. But many of the scientists I talked to sort of disabused me of my assumptions about that number because the Gulf is an incredibly complicated place, and surface temperature is just one aspect of what is going on in the system. So I'm going to read about the Gulf. Growing up on its coast, I always held a naive conviction that the Gulf of Maine is a special place, unlike anywhere else in the world. The scientists who study the Gulf know that it is, in fact, special in immutable ways. It is sometimes described as a sea within a sea, because although it is a corner of the North Atlantic, it has its own peculiar bathymetry that governs its circulation. It is a long depression in the continental shelf, from the lee of Cape Cod to the Bay of Fundy, which was scraped out by glaciers that only receded 10,000 years ago. It is bounded by George's Bank and Brown's Bank on the Scotian Shelf. These raised underwater plateaus, forested with kelp, were once broad islands where mammoths and mastodons roamed. They still serve as bulwarks against the Atlantic, a birdbath on the brink of a lake. Warm water from the Gulf Stream enters through the Northeast Channel, which drives deep between the banks. Cold, salty water, derived from ice formation in the Arctic, enters the Gulf on the Labrador Current, which skirts the coast of Greenland and washes over the Scotian shelf. The Gulf is in the sway of its own physics, its long rectangular basin sloshing the incoming sea back and forth out of rhythm with the planet's tides. Twice a day, 110 billion tons of water are sent rushing into the Bay of Fundy and then sucked back out. Nutrients are mixed and transported for miles. These waters are some of the most productive in the world. When Pangaea split and the world's waters rushed in to fill the fissure, the new ocean was inoculated with species from the Pacific. Not all species could make this migration. Marine mammals that are keystone species in the Pacific, like the sea otter and the killer whale, are absent from the North Atlantic. Instead, the Atlantic is dominated by predatory fish. People have been fishing in the Gulf of Maine since the retreat of the Laurentide ice sheet at the end of the last ice age. A Stone Age community of hunter-gatherers, known as the Red Paint People, settled the shores of the Gulf some 6,000 years ago. Sustained by the bounty of the ocean, they never practiced agriculture, but they were a startlingly advanced society with complex burial rituals and elegant slate bayonets. Arrowheads aren't the most interesting artifacts of this period. It's the shell middens, eroded along the coast by sea level rise, that hold the most valuable information about the Gulf's ecological past. Those ancient landfills are filled with the jawbones of codfish and the vertebrae of swordfish. For just about as long as there have been fish in the Gulf, people have been fishing for them. The Gulf has as many horizons as it has islands, and nobody knows the whole thing. Like the story of the blind man and the elephant, every person you ask, even the most expert, will describe a different Gulf to you and a different crisis. What do you call a lobster fisherman that's more than 10 miles away from home? Moffat asks me. I've heard the joke before. Lost. And I'm going to read one more section, but first I want to talk about the process of reporting this story. I tried and failed to finally get my driver's license in January, and so I had to pay my teenage sister to drive me around Maine for a week, which we had a great time. We worked our way up and down the coast, visiting various research institutes, and the car got caught in a blizzard and broke down. When we were brainstorming thesis ideas, everyone told us to find a way to report somewhere in the Southern Hemisphere or otherwise warm or exotic so that you could travel during the winter. And instead I chose to write about Maine in the winter. So that was challenging, but I needed to shout out my sister here because I'm very grateful to her. So one of the challenging things about writing a thesis with a topic this broad is that every person you talk to will tell you something that will dramatically change your idea of what the stakes of the piece are. And one of these conversations that I had that sort of like changed my thinking about the Gulf was with John Hare, who is the director of the Northeast Fisheries Science Center, which is a center that informs the management bodies of the Gulf fisheries. So they go out and do the science that then informs like how many, what the fishing quotas are for different species and how to manage resources in the Gulf and take climate change into account. And the three groups of people that I spoke to were fishermen, scientists, and people who work in management and policy. And these groups are historically at odds with each other. They all want something slightly different, and they all have a very different perspective on the Gulf. But John was a really interesting person to talk to because he had worked as a scientist for many years and recently became involved in management, and it had kind of broadened his thinking on the subject. But he was the first person who told me about the natural climatic cycles that the Gulf is exposed to. So I'm going to read a bit about the recent history of the Gulf, not the glacial history, but the last 100 to 200 years. The most frightening aspect of climate change is its unpredictability. It's not going to be a Dead Sea, Alden told me. It's going to be something. It's just whether we know how to make our livings from it and do it right, and we won't have anything to go on. The Gulf of Maine seems to have reached the frayed edge of precedent sooner than the rest of the world. So there is something uncanny in the fact that much of what we are seeing in the environment has happened before. Curious changes have been taking place, wrote Rachel Carson, with many animals invading this cold temperate zone from the south and pushing up through Maine and even into Canada. She was writing from her home in Boothbay Harbor in the year 1955. The changes were certainly notable. A menhaden fishery, unheard of earlier in the century, was flourishing in Maine. Not only did yellowtail flounder and silver hake hazard around the arm of Cape Cod on warm currents, but their young grew to maturity in the balmy waters of the southern Gulf. Whiting could be found in all seasons on George's Bank. The odd seahorse, six-gill shark, and triggerfish made its way up from the tropics. And lobster exploded in Maine. Landings more than doubled from 7.6 million pounds in 1940 to 19.1 million just 5 years later. We hate to squawk about climatic changes, a reporter for a fishing trade journal had written in 1949, but there may be something to it. In 1957, the Fish and Wildlife Service published a report titled Climatic Trends and the Distribution of Marine Animals in New England. It was a data dump, offering little analysis, but an array of incontrovertible facts. Air temperatures since 1900 had been warmer than average, and between 1905 and 1949, there had been a trend of warmer winters and milder summers. For many years, the authors wrote, Americans have commented on an apparent warming of their climate. Older people have referred to the old-fashioned winters they once knew. Climatologists long shrugged off the idea as unfounded, but amelioration in climate is no longer confined to the popular mind. A decided trend toward warmer winter during the past 50 years is now well documented. By the time of the report, that trend had actually begun to reverse. In 1960, fishermen were complaining about the scarcity of lobster, and coastal fisheries were icebound during the winter months. The creeping cold was met with even more panic and negativity than the runaway warming had been. In the 1990s, climate researchers began to chart sea surface temperature in the North Atlantic, records for which only go back about a century and a half. They found a pattern of 70-year oscillations between warmer and colder than average periods, a natural climatic fluctuation that, they argued in Nature, had obscured the signal of warming from the greenhouse effect. Tree ring data has provided evidence that these cycles of warming and cooling have been going on in the Atlantic since the 16th century. Rather than creating nuance in the discussion of climate change, the evidence for natural oscillations in climate was exploited by global warming skeptics, and the Atlantic Multi-Decadal Oscillation, the AMO, became a byword for climate denialism. Michael Mann, the climatologist who first named the AMO, later admitted that he felt he had helped create a monster. Depending on who you talk to, some people might think that sort of long-term climate change is a bigger issue, or shorter-term decadal variability is a bigger issue. John Hare, director of the Northeast Fisheries Science Center, tells me. Regardless, both phenomena are happening in tandem. The runaway warming of the Gulf and the 99.9% figure could be read as an amplification of the Atlantic's natural cycles by the greenhouse effect. 2012 was the AMO's peak, Hare says. The Gulf could be headed for a cool down. The reassuring prospect of cooling isn't the aspect of the AMO that preoccupies Hare. Rather, it reveals a short-sightedness and an amnesia in the institutions he's part of, which supply the best available scientific data with which to manage fish stocks in the Northeast. That idea of ecosystems being variable and changing kind of slipped away, he says. We can't let the opportunity to make management more adaptable slip away. We had an opportunity in the late 50s, early 60s, but as a society, as a profession, and as a region, we didn't take advantage of it. So I'm gonna end with that idea, which is how I came to understand the sort of short-term anyway, climatic changes in the Gulf, which is that there are sort of many ways to look at warming and the future of climate change, but it doesn't, much of it is about our own perspectives on the environment and the ability of our institutions to change and adapt, and that's almost more important. The way that we use these changing resources is going to be more important than the sort of climatic changes in the environment, if that makes sense. So I'll share here a couple more images from Stonington. You can see lobster are everywhere. And that's the end of my presentation.
Thank you so much, Lucy. That was wonderful. And it made me hungry.